Hello and welcome to naming hydrocarbons. Hydrocarbons are organic compounds that only have carbon and hydrogen in them. What you will need to do to have open in order to follow along with this video are reference tables P and Q. There are several types of formulas. If we looked first at, I'm just going to go with the example pentane. Pent means 5. As you can see from reference table Q, ane endings mean all single bonds. So pentane is 5 carbons in a row with all single bonds. A complete structural formula, which is what we'll mostly focus on today, would have 5 carbons in a row. And then we fill in hydrogens on them, and we'll talk about how we're doing that today. So it's called a complete structural formula because we can very easily see where all the hydrogens are, which carbons they're attached to, where the bonds are, and it's very drawn out. So we will deal with mostly drawing those. A condensed structural formula is a way of showing this that just kind of scrunches everything down a little bit. So if we look at this guy right here, this is like a CH3. Each of these guys in the middle are a C with 2 H's. And our guy on the end again is the CH3. So this does allow us to see where the hydrogens are attached, kind of how the carbons are arranged. It can also show double and triple bonds, but not quite as much space taken up by drawing this. We can also completely condense this to a molecular formula. There are a total of 1, 2, 3, 4, 5 carbons, and if we add up our hydrogens, we get 12. Molecular formulas are great if you need to do a GFM or something like that, or just kind of classify compounds sometimes, but they don't show us much about the structure of the molecule. So we name hydrocarbons using something called the IUPAC naming system, which is the International Union of Physical and Applied Chemists. First thing we do is we identify the longest carbon chain. That'll usually be pretty simple and straightforward. So it's just these carbons that we have in a row right here. And I did also show you what this would look like condensed, so you can sort of get used to those. And I like to make a habit of numbering these. 1, 2, 3, 4, 5, 6. You can also number in the other direction. We'll talk about times when that matters a little bit. But the IUPAC system is very systematic. So I like to kind of have you make some good habits with that. Now, based on my number of carbons in a row, I have 6 carbons in a row. So you're going to go back to your prefix table. When we have 6 carbons in a row, our prefix is hex. So this name is going to start with hex. Then I go to table Q to assign a suffix. So I have all single bonds. The example on table Q that shows single bonds are the alkanes. So the ending of this name is going to be ane. Sometimes we have something called substituents. Those are groups that stick off. You'll see those in other examples. This does not have substituents, so we're able to skip step 5 and go straight to step 6. Do we have any multiple bonds? That means double or triple bonds. We do not, so we can put it all together, and this compound is called hexane. Now, my next example will let me look at how numbering can be important and also deal with substituents. So in a row in this compound, I have 1, 2, 3, 4, 5, 6, 7 carbons. I'm going to number these in both directions. I'll show you why in just a minute. So I have 7 carbons in a row. So that gives me the prefix hept. The next thing I actually have to deal with now, gotta do my ending first. Still all single bonds, so I'm still going to have an ane ending. Now we have a substituent. Now you might have said before, oh, there's really 8 carbons total there. Well, this 8th guy right here is something we call a substituent or a branched group. It sticks off of the main chain of carbons. These do take a little bit of practice. So it's not one of the carbons in a row. It's kind of coming off like the branch in a tree. And there's 1 carbon in that substituent. So the prefix for 1 carbon is meth. So we call this a methyl group. We also have to tell people where that methyl group is. Now, if you numbered this way, that methyl group would be at carbon 5. If you numbered this way, that methyl group would be at carbon 3. When we name hydrocarbons, we want to always be consistent. Molecules can move in space, so we want to have a systematic way of numbering. So we have to pick the lowest possible number. So you say to yourself, which number is lower? Oh, it's 3. So we're going to call this 3-methyl. We don't have any multiple bonds. We have no double or triple bonds. So now we can put this together. We put the 3-methyl first, then the hept, and the ane. Then we're going to identify the longest carbon chain. 1, 2, 3, 4, 5, 6 in a row. Since we have 6 in a row, this is again going to be hex. We have all single bonds. Our ending's again going to be ane, so that's fairly straightforward. Now with our substituents here, and these are very often shown condensed even in a structural formula. With our constituents here, we could either say that they're attached to carbon 2 or carbon 5. 2 is a lower number. So we're going to call this 2,2-di, because there's 2 of them. Each one has 1 carbon, methyl. We do not have any double or triple bonds. We don't need to worry about that. So this is 2,2-dimethyl hexane. So indicating, I know it might seem a little redundant, but we do want to show both of those are attached to carbon 2. So our next group right here adds a level of difficulty because we have a methyl up here and an ethyl down here. So as you get better at these, you can probably see that it's going to make sense to number this way. 1, 2, 3, 4, 5, 6, 7, 8. So we're seeing that we have this guy attached to carbon 4 and this guy at carbon 2. If you numbered in the other direction, those numbers would end up being higher. So this is what's called a methyl group because there's 1 carbon in it. This has 2 carbons, so it's an ethyl group. And we have 8 carbons in a row. So this is oct, all single bonds, so ane. So this is going to be, and you can put the methyl and ethyl for right now in either order. I'm going to just go in the order that they are on the compound. So I have 2 for my methyl, 4 for my ethyl. I do not have any double or triple bonds, so I'm going to combine this all together. And you can actually really do 1 or 2 things, and I'll consider it correct. So 2-methyl, 4-ethyl, and then I have 8 carbons in a row, no triple bonds or double bonds. Octane. If you wrote this, that's awesome. It's actually technically a little bit more correct because the substituent should go in alphabetical order. When you do have a double bond or a triple bond, we deal with that by going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We want to see where the double bond starts and give it the lowest number. If we numbered this way, our double bond starts at carbon 3. If we number this way, our double bond starts at carbon 2. I also indicated over here, you'll notice the double bond is right there. You can see there's no 2 attached to this H, so that's a little bit of a clue there. So if we numbered this going this way, we get a 2, so that's what we want to do. We have 5 carbons in a row. 5 carbons in a row is a pent. Because we have a double bond, we go to table Q, and this should end in ene. We don't have any substituents. There's no branches. Our number for our multiple bond is 2. So we're going to put this all together, and this is called 2-pentene. Now, if you're given just a condensed formula, you might have to draw it out to know what kind of bond you have. So I'm using a little bit of shorthand here for these 3 hydrogens. I'm just indicating them with these steps. So my first carbon has 3 hydrogens. My second has 2. My third carbon has 0 hydrogens. My fourth carbon has 0 hydrogens. So 1, 2, 3, 4, 5, and 2 H's, 6, and in CH3. That tells me that 1, 2, 3, 4. There's a triple bond there. And we'll do a little more practice. That'll get easier. So if I number this way, my double bond starting at 3. I number it this way, it's starting at 4, so that's not going to work. I have 7 carbons in a row, so I'm going to jump down. This is a triple bond, so it's an ine ending. So this is going to be 3 heptine. Okay, so that indicates the 7 carbons. This indicates the triple bond. That tells where it is. So I'm going to have you pause the video for a moment, and then you can take a look at these answers, give these each try. So you have pentane, 2 heptine, 2 butene. With propene, we actually get away with no number. If you did put 1, that's totally okay. The reason for this is if we flipped this molecule around, if we flip this molecule around and we drew it in the other direction, no matter which way we show it, that double bond's always starting at carbon 1. But again, if you wrote true propene, that's okay. This one, again, the methyl or ethyl can go first. Beast, pretty tricky stuff. So we'll practice these a little bit more in class. When you need to draw hydrocarbons, you're going to first look at table P to draw what's called a carbon backbone. So this is based on my prefix. Pent means 5 carbons in a row. So you just attach 5 carbons with single bonds between them. Then you determine if you have any multiple bonds, substituents, anything like that. Ane tells me these are all single bonds, so I leave them as is. So at this point, I've determined if I have any multiple bonds. I'm done with that. These are all single. I have no substituents. There's no methyl or ethyl in the name. Now, every single carbon has to hold 4 bonds. So if we don't have multiple bonds or substituents, we fill those in with hydrogens. So I go to each carbon. This guy currently has 1 bond, 2, 3, 4. And you can use those just as stems. We'll get used to that. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that's pentane. Step it up a little with 2-methyl heptane. So the first thing I do is locate the part from table P, which is hept. 1, 2, 3, 4, 5, 6, 7. Now, I have ane on the endings. These are all single bonds. So my single bond part is done. I have a methyl group on carbon 2. So I'm going to count. This will be carbon 1. This will be carbon 2. You can count from the other direction, but I just prefer to go left to right because you're used to doing that from reading and things. So on carbon 2, I'm going to put a CH3. To show you this structurally, I'll do that. I kind of like to show it the condensed way. It's a C with 1, 2, 3 H's on it. That starts to take up a lot of room. So I think that works a little bit better. You are allowed to do shorthand for your hydrogens, which are just showing their little bonds. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Just be comfortable with understanding that those do mean hydrogens and not lines, and make sure that they're very visible. If you have one that's really light, you can actually lose points for that. So this one's a little bit trickier. We got oct right here, which means 1, 2, 3, 4, 5, 6, 7, 8. I'm going to just go from left to right with my numbering. On carbon 1, 2, 3, I'm going to put an ethyl group, which has 2 carbons. Its formula is CH2, CH3. So that first carbon can only fit 2 hydrogens on it. I put that up above. You can put it below. On carbon 2, I'm putting this methyl group below just because there's more room down there, and I'm doing the same thing here on carbon 4. And then I just have to go and fill in my hydrogens. But I did have all single bonds here. Sorry, I forgot to mention that. Still an alkane. Now, this one right here, we have pent to start us off with. So 1, 2, 3, 4, 5. The YME tells me I have a triple bond starting with carbon 1. I'm going to number this way. So this is my carbon 1. Put a triple bond there. Now, the only thing left I have, I don't have any substituents. I have to make sure everyone has 4 bonds. This carbon, my first carbon, already has 1, 2, 3, 4. Oh, that's it. So a lot of times this is shown over here like this. This carbon has 1, 2, 3, 4 already. No hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Again, you can show those just as sticks. That's okay. For 4-octene, so oct is 8. 1, 2, 3, 4, 5, 6, 7, 8. Go 1, 2, 3, 4 in. That's where we start our double bond. And then all we have left to do is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So take a moment, pause the video, and try these out. So propane, 2, 3 heptene. So this goes 1, 2, 3 in. You could number from the other direction. Just be cautious. I prefer to usually just go from left to right and make sure each of these don't only have the 1 hydrogen on them. Be very careful to check that out. Ethyne, again, you need no number because there's nowhere else that can go. 2-butyne, those can't hold any other hydrogens in the middle because that triple bond. Kind of angled that ethane to help it, or ethyl to help that fit there. So I gave you a tricky one with this because we had a double bond kind of falling in the middle, and that 4 was showing that double bond right there. And that concludes naming and drawing hydrocarbons.